Aloha, oh, aloha. Let's go ahead and go on to 3.6, the chain rule. Don't you dare touch the inside. All right, here we go. Let's check this bad boy out. The chain rule. Okay, and I'm going to start going over this a little bit quicker. My guess is you're probably getting a little bit annoyed of this beginning, but too bad. It's topic 3.1, the chain rule. There's your enduring, understanding, learning, objectives, essential knowledge. If you're into it, hit that little pause button, but if not, here we go. Let's roll. All right, the chain rule. One of the coolest things that we do all year is the chain rule. It allows us to do some really tough, crazy derivative problems. Okay, and we kind of have a little bit of an introduction here. Okay, you guys, so let's take a look at it. Find f of g of x. So that's a composite of two functions. And remember, the way we used to do this old school is that'd be f of, let's put g of x in there, which would be 2x minus 1. And then we're going to take the f of 2x minus 1, which would be 2x minus 1 squared. Okay, so there it is. Now let's say I happen to say, hey, take the derivative of that composite function. Okay, hit pause. What's your guess? Well, hopefully you hit pause. Hopefully you took a stab at it. Let's take a couple of guesses here. Well, one, it kind of looks like a power rule. So that would mean drop that 2 and subtract 1 from that exponent. 2 minus 1. Is that the right answer? Another thought that you may have had would be this. Let's go ahead and drop that 2. Okay, take 1 away from it, and then take the derivative of the inside, which the derivative of 2x minus 1 would be 2. Okay, those are different answers. I wonder if one of those is right. To see if one of those is right, let's go ahead and take this composite function and let's expand that bad boy. If I were to expand that, I would get 4x squared minus 4x plus 1. Okay, now let's take the derivative with respect to x of 4x squared minus 4x plus 1. And we were doing this, right, class, in some of the earlier sections. And I get 8x minus 4. Oh, snap. That is neither of those. So don't you dare do it that way. So you could do it by expanding it, but you actually could do it that way as well. And we're going to go ahead and introduce a way of how to do it that way. Okay, and here we go. Just a real quick real-life example here of how we can turn a regular problem here into kind of a derivative. And remember, derivative is a rate, which is instantaneous rate of change. But we have Jasmine here running a 400-meter dash. So the change in position would be 400 meters. And Jasmine does add in 240 steps. Okay, and this is just going back to kind of your science days, right, where you're dealing with units. And we're going to multiply that by a conversion here, and we're going to get a rate out of it. All right, and she runs, it says 3 steps every 1 second. So that would be 3 steps, right, class? 3 steps right up there per 1 second. And bang, bang, choo-choo train. Haven't heard that in a while. Cross those bad boys out, and we get, what is that? 1,200 over 240 meters per second, right? You do a little simplification there, and I get 5 meters per second, which is a rate, which is kind of like a derivative. Okay, so if we go ahead and take a look down here at what the chain rule is all about, okay, there's the chain rule. Okay, if y equals f of u is a differentiable function of u, and u equals g of x is a differential function of x, then our composite function is a differentiable function of x. Well, what the heck does all that mean? Okay, and that looks a little bit crazy even right there, okay? But here's kind of more notationally what we use, okay? And it is, what if we take the derivative of a composite function in terms of x, okay? That would simply be equal to, we take the derivative of what we call the outside function. We don't dare touch the inside function. And then we take the derivative of the inside function. And when we do that, we get a correct derivative for anything that is a composite of two functions. So here are a little bit of notes that you want, okay? This right here, okay, means you take the derivative of the outside. Okay, derivative of the outside. And we always want to say something as we take the derivative of the outside. Don't you dare touch the inside. First person that yells that when you're supposed to tomorrow gets a little bonus. Okay, and then after we do all that, we take the derivative of the inside. Okay? So we're going to practice some of these bad boys. It's kind of like practice makes perfect here. If something's not good or you need a little bit of extra time, go ahead and take some extra notes. All right, here we go. Let's do the problem that we did earlier, but let's do it the way we are supposed to, okay, which was our warm-up using the, now we're going to use the chain rule. Okay, what's the chain rule? I have an inside and an outside, and I think one of the best things to do to get used to this is always let u equal whatever's on the inside. And if you were asking me, I would definitely say 2x minus 1 was the inside. So if you think about it, it's like having just a problem u squared, okay, with u being the inside. Well, we all know that's just a power rule. And how do we do the power rule? We drop that exponent, right? If we take the derivative, let me kind of have great notation here. Let's take the derivative of this bad boy. Okay, we take the derivative of the outside. The outside is the power rule. So I drop that 2. Don't you dare push that inside. And then you subtract 1, right? That's what the power. 2 minus 1 is 1. But then we're going to multiply it, and this is kind of correct notation. You do not have to show this. Then we're going to take the derivative of just the inside. Well, what's the derivative of 2x minus 1? It is 2, right? So kind of doing some simplification here. I get 2x minus 1. The derivative, actual derivative of that inside would be 2. And then I could do some simplification, right? That'd be 4 times 2x minus 1, which would be 8x minus 4. And remember, we got that when we expanded, and then we did the power rule, right, class? Here we go, example 1. I kind of got in the way there. Hit pause if you need a little bit of additional time to write some notes. Okay, but let's go ahead and look at h of x. Okay, we all know from that previous lesson, the first thing I'd want to do in this problem is definitely rewrite this bad boy, right? It has a rational exponent. And when I rewrite it, please get used to this if you're not following along. Let u equal x squared plus 1. That would mean it'd be u to the 1/2. That's the problem I'm doing. So u would be in the inside. Kind of obvious for a lot of these, right? The inside's going to happen to be in actual parentheses. So I'm going to take the derivative of the outside first. So let's go ahead and do the derivative. Okay, of x squared plus 1 to the 1/2 power. Okay, and let's take the derivative. U is the inside. Derivative of the outside would be a power rule, which means we drop that 1/2. X squared plus 1. Take 1 away from that, I get a negative 1/2 times the derivative. I'm not going to show that notation anymore because I think you guys will start dropping it. And we're going to take the derivative of that inside. Derivative of the inside would be 2x plus 0. Right? Let's do a little simplification. Oh, snap. I got a little 1/2 and a 2 out there. I'm going to put an x there. And if I wanted to, you know, like I said, in AP Calc, we do like negative exponents. But if you want to get a little crazy, and if you do get crazy, you just better make sure you do it correctly. That's another way to represent that answer. Right, class? Okay? Now, if you're feeling good, I challenge you. Okay? Maybe I'm not on the next one now that I just took a quick little peek at it. But anytime you think you can do a problem, I think really good practice, class, is to try things on your own. This one's a little bit different. Okay, why is it a little different? Well, they tell me to take the derivative of y with respect to t. Oh, snap! There's no t in that problem. Are there any typos? No, there isn't. But I noticed that there's no t. What do I do if there's no t? Well, it's kind of like we have an inside and an outside. Well, what do I do here? I guess the only way I could rewrite this problem would be like this. Tangent of x. So I could maybe pretend like x is on the inside. So that's the part I'm not going to touch. Okay, so let's go ahead and take the derivative with respect to t. What would that be equal to? Well, I would probably say if x was on the inside, what's on the outside? Class? Tangent. And we learned last lesson that the derivative of tangent would be secant squared. Don't you dare touch the inside, right? I didn't touch it, but then what do I have to do? I have to take the derivative of the inside. And the derivative, the inside is x. And usually the derivative of x is 1, but that's when we take the derivative with respect to x. Since they're asking us to take the derivative with respect to t, we just write, hey, the derivative of x with respect to t. You're going to find out later how that guy is really important. But this is actually the answer to that problem when the variables don't match up like that. Hopefully that's okay. If you need some help or have any questions, bring them early in the morning or to class. All right, example 3. We're mowing through these bad boys. Each of the following examples can be done without using the chain rule. First, state how to find the derivative without using the chain rule, and then use the chain rule to differentiate. So here we go. Come on, challenge yourself. Hey, how do we do that without the chain rule? Right now. Quotient rule. All right, so you could do the quotient rule there, but believe it or not, I could do this using the chain rule. How? I don't see an inside, I don't see an outside. Well, we rewrite this bad boy, okay? We write f of x is equal to 2. I could rewrite that as 3x plus 1 to the negative 1 power. Oh, snap, I got an inside, right? 2 would be a coefficient. Let's take the derivative. Okay, that'd be a chain rule. 2 is just, remember, just a constant. So that boy's just hanging along for the ride, okay? And so I do the my u once again, if I want to go old school, and I'm going to stop doing this, okay? But if you're struggling with inside, outside, you got to do that. The inside would be 3x plus 1, and the outside would be to the negative 1, right? That'd be u to the negative 1, which would suggest power rule. So I drop that negative 1, and I get a negative 2. Don't you dare touch the inside. I subtract 1, that gives me a negative 2, but then I have to multiply it by the derivative of the inside, and the derivative of 3x plus 1 is 3. Let's write the final answer a little bit cleaner. That'd be negative 6, 3x plus 1 to the negative 2. Booyah, problem done. You know what? If I did that problem using the quotient rule, you would have got an answer that just looked like this. Remember what goes on the bottom? Low, low. All right, done. B, how could you do that without the chain rule? Well, be a little crazy. We could use a little Pascal's triangle, right? Expand that bad boy and just use the power rule. But watch, that would be a lot of work. I'd have to remember Pascal's. I'd have to maybe do x plus 2 times x plus 2 times x plus 2. Or let's just get a little crazy. What's the inside? What's the outside, right, class? So g prime of x for this bad boy. Watch how fast this is. Drop that tree with the power rule. Don't you dare touch that inside. 3 minus 2 minus 1 is 2, right? Then I have to take the derivative of the inside. Oh, that's just 1. So it'd be 3 times the quantity x plus 2 squared. Okay, and maybe on the AP, if it was a multiple choice, you might have to expand that, distribute the 3 in there, and then you would be done. Okay, let's take a look at the next one. How the heck? I'd be really impressed if you know how else you could do C. Believe it or not, you could use your double angle identity. Do you remember that? Sine 2x, believe it or not, is equal to 2 sine x cosine x. Then, believe it or not, you got a little product rule going on if you find that derivative. However, watch how quick this is using the chain rule. Okay, h prime of x is equal to, what's the outside? Well, the inside will be the parentheses. Remember, that usually is a good indicator. So the inside is 2x. The outside would be sine, and the derivative of sine is cosine. Don't you dare touch the inside. Times the derivative of the inside, and the derivative of 2x is 2. And then you know what? You do want to write this prettier. If not, you could get some points off you if you unfortunately write something down incorrectly. Like some people will put 4x, right? That 2x is stuck on that inside. All right, let's keep on rolling, 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 rolling. Oh, you need the arrow. All right. Now these get like so fun. Come on. I'm making these videos shorter. So do yourself and myself a favor. Try these next 2 right now by hitting pause. All right? Okay, hopefully you had a shot at it. Hopefully you weren't weak sauce and you gave it a shot. And let's see if we get the same answer, okay? If you look here, wow, I kind of have like a U and a V. Right? So even to start this problem, I'm going to rewrite this. Right? And if I have a u and a v, it's kind of like I have 2 functions. Right? There's one of them. And then, right, we always want to write with negative exponents or rational exponents. And there's 2. So it's kind of like having a u and a v, which would suggest the product rule. And guess what? When I do the product rule, I get to use the chain rule. Okay, so let's go ahead and do this. Derivative of k prime of x. All right? So how do we do this bad boy? We write down our u, which is x squared plus 1. Remember, when you do the product rule, it doesn't matter which order you do it in. And we're going to multiply that by the derivative of v. Well, what's the derivative of v? Oh, it's the chain rule, right? My inside's 2x minus 3. my outside is u to the 1/2, so I drop that. Don't you dare touch that inside. Finish your power rule. Okay, that's a 2. And then take the time, multiply it by the derivative of the inside, which would be 2. Plus, so fun, I'm not even done yet. I multiply it by the v, which is 2x minus 3 to the 1/2. And I multiply that by the derivative of x squared plus 1. Now that is not, right, class? That is not. That's just x squared plus 1. That's not a chain. That's not a chain rule. So that's just a derivative, and that would just be 2x. Now let's clean this bad boy up. When I clean these up, it's just good to keep the order the same, right? That would be x squared plus 1 times the quantity. Ooh, that 2 and that 1/2 cancel to be 1. So I get 2x minus 3 to the negative 1/2 plus, I'm going to put the 2x in first, right? Kind of keeping the polynomials out in front, okay, with 2x minus 3 to the 1/2. And you can make things look prettier, right? Negative exponents you could put downstairs. And we could clean that up a little bit, but you know what? That's Algebra 2 stuff. You guys probably would rock that out, all right? Here we go, example 5. If you didn't have a shot at this bad boy, hit that pause button, okay? And give it a shot. I'm going to erase just so it looks a little cleaner, okay? Oh, sweet. Sweet, sweet, sweet. That looks like when I take the derivative of that, my u is that whole entire inside, right? That whole thing is u, so it's like having a u to the 9th. Well, what do I do if it's u to the 9th? That's the power rule, which is drop that 9. Don't you dare, class, touch that inside, right? And t's are okay this time because we're finding the derivative with respect to t. Okay, and then I subtract 9 minus 1 is 8, but then I have to take the derivative of the inside. It's always good to put a parentheses here, right? Because I'm multiplying by the entire derivative. Oh, nice, I get to do the quotient rule, right? Because if I took the derivative of just the inside, that'd be a quotient rule. And if you're struggling, you kind of do a little side work. You come over here and you say, okay, let's just write down what u is. And if this was a problem on our quiz we just took, you should be able to find the derivative of that using the quotient rule, which is low 2t plus 1, right? Times the derivative of the high, which is 1, minus the high, which is t minus 2, times the derivative of the low, which would be 2, all over low, which would be 2t plus 1 quantity squared. Oh, snap. How do I clean this bad boy up? There's some important ways that we could clean this up. Sometimes on multiple choice type tests or questions, you could get confused. So let's take a look at this. On the top, I get, what is that? 2t plus 1. Let's distribute a 2 and the negative 2t, right? I think so. Yes, and plus 4 all over 2t plus 1. And I've seen this on a multiple choice before. They actually simplify that a little bit. If you notice, goner, and the 1 and the 4 become a 5, right? That becomes a 5. And that 5 can come all the way out in front to be 45. And then sometimes they'll write this. That's a t minus 2 to the 8th. And then how many 2t plus 1s do I have in the entire problem? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And sometimes I'll write it like that, okay, just so you kind of have another familiar way of doing it. I accept a lot of answers for that. We like to simplify as much as we can, though. All right, class? Okay, here is the chain rule, example 6, but a little bit differently. And when I looked at this problem, these really should be f of 5 problems, okay? But for each of the following, we're going to use all of these facts right here. So we're going to use that information, and we're going to do these problems. If for some reason you're not able to do the problem, you have to tell me what you were lacking or what you needed, okay? So let's go ahead and do this, all right? And we're going to take the derivative of each one of these guys. I don't think it really says to find the derivative, does it? No, we should add a little bit better directions here, okay? But let's take the derivative. Let's take f prime of x. What would f prime of x be? Well, that would be a product rule, right, class? Product rule is you have your g and you multiply by the derivative of h. Remember, when you're dealing with the product rule, since it's addition, it doesn't matter what order we do our derivatives in, okay? And then you have h of x times g prime of x. And like I said, I think the question was supposed to be asked, what's f prime of 5? Which would be g of 5 times h prime of 5 plus h of 5 times g prime of 5. Okay, this little additional information thing means I better be careful. Do I have enough info? Let's check it out. G of 5 is -3. H prime of 5 is -2 plus h of 5 is 3 and g prime of 5 is 6. Oh, enough info for that stuff. What is that? 6 plus 18 equals 24. Okay, not bad, not bad. Okay, challenge you once again. Hit that pause button. Take a shot at the next one before I get to it. Okay, but I'm going to start. I'm just going to keep rolling, all right? But I know I have to keep those answers up there. So there we go. I think I gave myself enough room. Let's check it out. Booyah. F prime of x. What the heck would I do? Oh, snap. That's got an inside, right? U is h of x. That's the inside. So the outside is g, right? It just represents some function. So I'm going to take the derivative of the outside. Well, how do I take the derivative of g? Well, it's just notation. Okay, class, it's just g prime. That means the derivative. Don't you dare touch that inside. Right, class? Don't you dare touch it. But then you have to multiply by the derivative of the inside. And like I said earlier, the problem was intended for you to find f prime, or the derivative of f, at x equals 5. Okay, so that means I'm going to plug in these bad boys. Let's check this out. There's my 5 times h prime of 5. All right, let's plug in some bad boys now. That'd be g prime of, please excuse my dear Aunt Sally, right? So I have to find h of 5 first. That's on the inside of my parentheses, and h of 5 is 3. Okay, h prime of 5 is -2. Now I have to find g prime of 3. Oh, snap. That's the additional information I needed, which means, hey, that's got to be the final answer to this problem, right? I guess I could write it fancy as -2 g prime of 3. Can't do it. Okay, so write down, I need some more information. You didn't give me enough. Okay? All right, hit that pause button. Try the next one. And I'm going to get rolling with it. I think it's our last one of the video. How about that? Important thing to notice. Those things mean the same exact thing. All right, so let's find f prime of x for this one down there. Oh, snap, that's a chain rule. What's the inside this time? It is g of x. Why? Because that 3 is on the outside. So it'd be like a u to the third, right, class? Which means we do the power rule, which is drop that 3. Don't you dare touch that inside, and then you subtract 1. But what do I have to remember to do? Multiply that by the derivative of the inside. So let's see if we got enough information to handle this guy. Ooh, snap, shame on me. F prime of 5 now, right? So we're going to go ahead and we're going to put a 5 in for those x's and see if there's enough information. 3, boom, g of 5. What's g of 5? Ooh, sweet. Right there, it's -3 squared times, do I have g prime of 5? Oh, sweet, times 6. Please excuse my dear Aunt Sally. 27 times 6. Oh, snap, what is that? 42, is it 162? Oh, I hope I got it right. I hope I got it right. Where's my solutions? I'm not going to do it the long way. Tell me I got it. I did. Sweet. And guess what? That is 3/6 done in about 25 minutes. Our videos, for the most part, class, are never going to reach 30 here. Okay? Bell, almost lunchtime. So make sure you're doing the worksheets at home, pretty please. That's how you're going to get great at this class. Aloha.